Certainly. Here's the passage with punctuation added. Without precedent for the historical backdrop of present-day humankind, the attractive North Pole leaps toward the South Pole, as well as the other way around. Our reality will be topsy-turvy for some time, and researchers are carefully trying to figure out what the approaching attractive shaft bounce will mean for the Earth. What is sure is just the advancement cannot presently be halted. The signs are disturbing, and the pole shift may have already started. Attractive pole shifts, otherwise known as geomagnetic inversions, have happened relatively frequently in the history of the Earth, but on land timescales, so the peculiarity is normal for the Earth, but an extraordinary event for us humans. Attractive pole inversions most likely happen, at least, every 200,000 to 300,000 years. The last completed pole inversion occurred about 780,000 years ago. This inversion, known as the Brunhes-Machiyama inversion, happened an unexpectedly long time ago. Finally, researchers express the following pole inversion might have already started. If the attractive North Pole leaps toward the South Pole and the other way around, the world's attractive field adjusts decisively in the direction of the leap. It even shows extreme shortcomings for a specific time frame. During this time, our human civilization is exposed to an increased risk for solar storms. Normally, the attractive field dependably catches the molecule streams from the sun, but when it weakens, more charged solar particles can infiltrate into the deeper layers of the Earth's atmosphere and potentially cause harm. If we then also experience a peak in solar activity, as is currently the case, it could become truly dangerous. Specialists warn that a large solar storm could paralyze our entire modern civilization. The span of a pole shift is 1,000 to 10,000 years. It sounds shocking and fascinating at the same time. A pole shift means a complete attractive inversion of our planet. North becomes south and vice versa. We humans have never deliberately experienced this cycle, and we don't know what a pole shift will be like. It might feel like nothing changes, or we might experience significant disturbances and perhaps huge failures of technical equipment. The attractive field isn't significant for us humans to live or consider this. The impacts of the Earth's attraction on us humans have scarcely been explored, if at all. Researchers expect that creatures use the attractive field for direction, and as already mentioned, the field protects us from the solar particle streams. These flows wouldn't be an issue for the globe, regardless of whether they happen at longer intervals and in concentrated explosions. Again, it's our modern human culture that is at risk because of our reliance on technology. Creatures and the planet itself can usually endure such changes very well. A pole shift is probably not an unexpected cycle. It might occur over 1,000 to 10,000 years. During this time, the attractive field weakens and becomes more turbulent, with the poles over and over shaking or wandering whimsically before realigning. Pole jumps happen as a result of changes in the flow patterns of the fluid metal in the inner core. This is where the attractive field is created, by an impact that researchers call the geodynamo, impacted by warm convection, the rotation of the Earth, and potentially other factors from space. The extremity of this geodynamo changes, and the direction of the poles changes with it. Current cycles in the Earth's attractive field are disturbing. The Earth's attractive field is currently changing in a striking manner. Over the past few years, the attractive field has lost around 10% of its strength. It is seen with concern that the attractive field continues to lose strength, and the rate of this reduction seems to be increasing. For quite a while, there has been a region with a harshly debilitated attractive field over the South Atlantic. This oddity is growing every day. Furthermore, in the worst-case scenario, it will spread to form a massive hole around here. Satellites and electronic gadgets are currently increasingly exposed to cosmic radiation, and no one knows where this development will lead. In the North, unusual changes have been seen since the 1990s. From that point forward, the attractive North Pole has been moving increasingly fast, from a couple of kilometers each year. The rate increased to around 50 to 60 kilometers each year. Right now, the attractive North Pole is moving toward Siberia. This still sounds incredibly northern to us, but there is a considerable distance between the original North Pole and its current position. Researchers recognize a few poles. Our Earth has a North Pole, which, measured along the Earth's axis, is practically permanent. Despite the fact that our planet has experienced axis shifts in its history, these events are less frequent than attractive inversions. Obviously, our globe also has an absolutely land North Pole at the top of the northern side of the equator. The attractive north is still determined by the pure revolution of the Earth's attractive field. Sure. Here's your text with punctuation added. Customarily, this large number of shafts go amiss somewhat from each other and don't lie simultaneously at one point. The attractive shaft is the most dynamic and it meanders the most. The attractive field doesn't encompass our Earth statically, it circles and vacillates. Phony problem, are we encountering a superchron? A few researchers are suspicious. Are we truly confronting a shaft shift, or is it all manipulator? The last post-hop around quite a while back was quite a while ago. Taking into account that such occasions happen on average every 200,000 to 300,000 years, researchers suspect that such periods without a shaft hop are similarly as typical as patterns of a few hundred years. There have been, obviously, deliberately eased periods in the Earth's history in which no shaft bounce happened for a few million years. Specialists allude to such stages as superons, and we could be in the center of one of these periods. During the Cretan superon, the Earth's attractive field stayed stable for around 30 million years. We could right now be in a comparable but more limited stage. The quake of the North Pole would then be a normal variance and not an indication of a total jump. The purposes behind an abnormally lengthy steadiness of the Earth's attractive field could be geodynamo mechanisms. The external planet center could be in a particularly steady stage by which the stream designs in the fluid iron are right now scarcely upset. Some scientists convincingly contend that geomagnetic inversions are turbulent and challenging to predict, so lengthy stops are normal. They express that without additional proof, it's unrealistic to without hesitation foresee a post-inversion for the following 10,000 years. What might a post-shift mean for our development? During a shaft shift, the Earth's attractive field will debilitate, which could imply that the Earth is briefly less safeguarded from radiation from space. This could debilitate nature and maybe additionally our bodies. In some ways, the specific impacts of a sharp decrease in the attractive envelope of our planet have not been adequately explored. Anyway, the fact that technological systems make it sure, like satellites and communication organizations, would be upset by the radiation. Notwithstanding interruptions to correspondence frameworks, we could experience blackouts. It's conceivable that more creatures will wander into regions where they don't have a place. Whales grounding themselves on shores is similarly possible, as large groups of birds getting lost. No one knows how rapidly creatures will adjust to the new circumstances and whether their internal navigation systems may adjust all the more rapidly to the new direction of north and south than our systems do. The degree to which a post-shift would influence the climate and environment is presently the subject of warmed banter. We simply don't have any idea what would occur if the attractive south turned into the attractive north, as well as the other way around. What is sure right now is simply a shaft shift would represent an extensive challenge for our innovative society. Researchers are presently observing each change intently so they can assess potential dangers at an early stage. How did the Earth's attractive field come about? It's really a supernatural occurrence. The Earth's attractive field empowers our planet to have a climate and, along these lines, permits us to live. Planets without an attractive field, for example, Mars, lose their climate if they ever had one. The geodynamo inside our planet is, therefore, a real fortunate turn of events. Inside the Earth, the turn causes electrically conductive fluid metal to be shaken this way and that, creating attractive forces. The Earth's center comprises a solid metallic inner core and a fluid outer core. Iron and nickel in the Earth's inner layer are softened by extreme heat from the inner core. A kind of convection current makes the fluid metal circulate like boiling water. The fluid iron is conductive, and its movement creates electrical currents. These currents, in turn, produce an attractive field. The Earth's rotation forces these convection flows into winding patterns. Researchers know this impact as the Coriolis force. Once produced, the attractive field enhances the developments in the fluid metal, making a steady cycle that keeps up with the geodynamo. The outcome is a worldwide attractive field encompassing the Earth like a giant bar magnet, forming attractive north and south poles. These cycles have been well documented and, possibly, explained by science. In spite of this, our attractive field is a logical supernatural occurrence. It appears impeccably organized, and without it, our world wouldn't be what it is. The magnetosphere shields the Earth from the solar wind. The Earth's attractive field diverts the solar wind so that it can't directly raise a ruckus around the town. The solar wind in a real sense packs the attractive field as the side facing the sun. As the side facing away from the sun, the solar wind extends the attractive field, making a long tail known as a magnetotail. In spite of this practically perfect defensive shield, the Earth gathers larger amounts of solar particles at the north and south poles and ties them in pocket-like fields. These regions were named after their pioneer as the Van Allen radiation belts. In 1958, the space expert James Van Allen saw for the first time how charged particles of the solar wind are caught and packaged by the attractive field. Once caught, these particles travel along the attractive field lines from one shaft to the next, gradually losing their charge. The inner layers of the Earth's atmosphere, consequently, remain perfectly safeguarded. If particles do manage to escape, exceptional conditions like the Carrington event can emerge. During this enormous solar storm, people in the 19th century experienced one of the strongest geomagnetic tempests of modern times. The sky appeared to be aburst with a play of tones, and ignites were flying from the telegraph establishments. The spillage of normal molecule streams into the Van Allen rings, when sufficiently extraordinary, produces a play of varieties that we know as aurora or polar lights. The aurora borealis forms in the north. The aurora australis makes the southern lights. Normally, these phenomena must be seen in the limit north or south. In 2024, the molecule barrage from the sun towards the Earth was so intense that the northern lights should have been visible well into the interior of the bodies of land. Some auroral lights displayed similarly to the Mediterranean area. Individuals on the tropical Pacific island of Hawaii saw the display for the first time with their own eyes, and in the southern hemisphere in Australia, and indeed, even in South Africa, were really glad by the strange polar lights. Click the subscribe button now to be the first to see all our new recordings. Music.